So imagine this. You're driving down the highway, right? And your gas car dies. It's a minor inconvenience.
Yeah, pretty much.
If a friend or a roadside assistance truck pulls up, they hand you a little plastic jerry can, pour in a couple gallons of unleaded, and, you're back on the road in 5 minutes.
Right. It's a quick fix.
But if your electric vehicle dies on that same highway, a tow truck might literally destroy its drivetrain.
Oh, absolutely. It's a completely different ballgame.
And that's what we're getting into today in this deep dive.
Yeah.
We're looking at why dragging a dead EV is just this absolute mechanical nightmare.
It really is.
And we're unpacking the mobile power plants that are, currently being deployed across the country to fix this very modern crisis.
Yeah, it's a fascinating shift in how we handle roadside emergencies.
So we're pulling from a whole stack of industry sources today, technical manuals, service breakdowns, and we're specifically looking at the expansion of the EE rescue network directly into the Atlanta metro area.
Right. And Atlanta is the perfect test case for this.
Exactly. Our mission today is to really analyze the mechanics, the economics, and honestly, the infrastructure of how this service actually operates on the ground.
Because, the transition to electric mobility, it's largely focused on the vehicles themselves, right?
Like the shiny new cars.
Exactly. And the permanent charging stations we see popping up at grocery stores or, highway rest stops.
Yeah, the hardwired stuff.
Right. But what's been severely under-discussed is the emergency safety net.
Which is kind of terrifying if you own an EV.
It is. We are looking at this fundamental shift from a centralized model where, this stranded vehicle has to be physically relocated to the energy source to a decentralized on-demand model.
Where the energy grid is essentially dispatched directly to you.
Exactly. The power comes to the car, not the other way around.
And the sources we have outline a very specific operational footprint for this Atlanta expansion.
They do.
EE Rescue is really targeting EV owners and commercial fleet operators who are out there looking for, Atlanta mobile EV charging.
Right. That's the core service.
They're rolling out a 24/7 emergency EV roadside service. And whether you're just an individual driver commuting in a Tesla or, say, a logistics manager overseeing a fleet of 30 electric delivery vans, the risk calculus of a dead battery is shifting fast.
It has to shift because the alternative is just too costly.
So I think we need to start by looking at the geography of this specific deployment because Atlanta is not just, a standard compact city grid.
Oh, definitely not. It's sprawling.
The service area covers a massive 45-mile radius from downtown.
Right. And visualizing that 45-mile radius, it really reveals the true scale of the logistical challenge here.
It's huge.
We are talking about an area that stretches all the way north, past Alpharetta, west out to Douglasville, east to Conyers, and just deep into the southern suburbs.
So that's what, over 6,000 square miles of coverage?
Easily. And Atlanta is infamous for its sprawl, right?
Oh yeah, the traffic is legendary.
Exactly. The city's design forces these long, high-speed commutes, often along the I-285 perimeter or those massive I-85 and I-75 corridors.
And while permanent charging infrastructure does exist, it's heavily skewed towards specific commercial hubs, isn't it?
Totally. You have fast chargers at places like Atlantic Station or those really upscale shopping centers in Buckhead.
Right.
But if you're commuting from a much more rural edge of that 45-mile radius or, you're stuck in standstill, bumper-to-bumper traffic on the perimeter in the dead of summer.
With the air conditioning just blasting.
Right. The disparity in charging access becomes this glaring, immediate issue.
Because the car is still using power even when it's not moving.
Exactly. The thermal management systems of electric vehicles are highly efficient, but they still draw significant power.
So sitting in extreme heat, or extreme cold for that matter, while stationary in traffic, that just accelerates battery depletion.
It does. And when a driver miscalculates that depletion, and this is a big one, a public charger on their route happens to be out of order.
Which, industry data shows happens far too frequently.
Way too often. And when that happens, the driver is stranded. Period.
And historically, the standard operating procedure for a stranded EV in Atlanta was, calling a tow truck.
Right, the traditional tow.
So let's spend some time on this standard procedure, because towing an EV is fundamentally different from towing an internal combustion engine vehicle.
It's night and day.
I really want to break down the mechanics of why a traditional tow is so precarious for an electric car. Like, what actually happens?
Well, the complication arises from the fundamental physics of an electric drivetrain.
Okay.
You cannot simply hook an EV up to a standard wheel lift tow truck. The ones that just grab the front wheels and drag it down the road with two wheels on the ground.
Right, because of the motors.
Exactly. When the wheels of an electric vehicle turn, they are physically and permanently linked to the electric traction
There's
motors.
no mechanical separation.
No. In almost all modern EVs, turning those wheels generates electricity. This is the regenerative braking system that normally, recaptures energy to charge the battery while you drive.
Okay, but if the car is completely dead, that system isn't functioning normally, right?
Exactly. So if a tow operator drags the car, the wheels turn, the motor spins, and electricity is generated.
Right.
But where does that power go if the computer system managing the battery is completely shut down?
Oh, wow. I didn't even think about that. It just backfeeds.
It backfeeds directly into an unmanaged system. You can send these uncontrolled electrical currents straight into the battery pack.
Which sounds incredibly dangerous.
It is. It can potentially cause severe thermal events like fires, or you can just physically destroy the internal components of the drivetrain.
Because with a gas car, an internal combustion engine, you have a mechanical transmission. You just shift it into neutral.
Right, you shift to neutral, physically disconnecting the wheels from the engine.
But EVs don't have that.
No, most electric vehicles do not have a true mechanical neutral in that sense. They use an electronic software neutral.
Ah, software. So if the computer is dead.
Yep. If the 12-volt battery that runs the car's computer is dead, you literally cannot engage that software neutral.
So you are generating this rogue electricity while simultaneously forcing mechanical components to turn against their design.
Exactly, which means an EV absolutely must be transported on a flatbed with all four wheels completely off the ground.
All four wheels off the ground, which I imagine introduces an entirely new set of logistical hurdles.
Oh, massive hurdles. First off, electric vehicles are incredibly heavy.
Because of the batteries, right?
Yeah, due to the density of the lithium-ion battery packs. A mid-size electric SUV can easily weigh 2,000 to 3,000 pounds more than its gas-powered equivalent.
That's a massive difference for a tow winch.
It is. And furthermore, when an EV completely dies, the electronic parking brake automatically engages.
Wait, it locks itself.
It locks itself. So the tow operator is now faced with dragging a completely locked, extraordinarily heavy vehicle up a steep metal incline onto the flatbed.
That sounds like a nightmare. How do they even do that without breaking the car?
They have to use specialized skates under the tires, and they're dragging the vehicle by its frame or suspension components.
Which has to carry risks.
Huge risks. It drastically increases the chance of snapping a tie rod, damaging the alignment, or worst case, harming the undercarriage where the battery itself is housed.
And if you dent that battery pack, the car is basically totaled.
Pretty much. And the financial and temporal costs of this whole ordeal really reflect this complexity.
Right, let's talk about the cost.
In a sprawling metro like Atlanta, requesting a specialized flatbed tow for a heavy electric vehicle will cost anywhere from $150 to upwards of $400.
Just for the tow.
Just for the tow. That fee only covers the physical transportation of the vehicle. It buys you 0 miles of actual electrical range.
So you're paying $400 just to be dropped off somewhere where you then have to pay more money for electricity.
Exactly. And the temporal cost is equally brutal.
Oh, I can only imagine.
Yeah.
Atlanta traffic alone.
Right. Waiting for a specialized flatbed, which takes longer to dispatch, then loading the locked vehicle, driving through congestion to an available fast charger.
Unloading the vehicle.
Right. Unloading it safely, and then finally waiting for the car to charge. That entire process could easily consume 3 to 4 hours of a person's day.
That is just catastrophic if you're trying to get to work or pick up your kids.
It ruins your day.
Which sets the stage perfectly for the specific technology eRescue is deploying in this market.
Yes, it's the perfect solution to this exact bottleneck.
So the service operating locally is known as Atlanta Mobile EV Charging. And they are using this specialized hardware called the eRoad Hero RH9K.
That's the one.
We really need to analyze the engineering of this equipment because it's not just a big battery they throw in the trunk.
No, not at all. The eRoad Hero RH9K is essentially a self-contained, highly refined mobile power plant.
A mobile power plant.
Mm-hmm.
Okay, what are the specs?
The primary specification we need to examine is its output. It is capable of delivering 9 kilowatts of continuous power.
Okay, 9 kilowatts.
With an 11 kilowatt peak output.
To put that in perspective for people, what's a normal charger at home do?
Good question. To establish a baseline, a standard level 1 charger, which is simply plugging a car into a standard 120-volt wall outlet, delivers about 1.4 kilowatts.
Oh, wow. So 9 kilowatts is a huge jump.
It is. A typical home level 2 charger, the kind installed on a dedicated 240-volt circuit, might deliver anywhere from 7 to 11 kilowatts.
So the RH9K is delivering the equivalent of a high-end home level 2 charger,
Exactly.
but it's doing it from the back of a truck on the side of I-285.
Yep, right where you need it.
But, okay, here's where I really want to push back on the underlying concept here.
Okay, go for it.
Because the source documentation clearly states that the RH9K relies on a 6.1-gallon gas tank to generate this electricity.
It does.
If a driver has purchased an EV specifically to, reduce their carbon footprint, isn't dispatching a gas-powered generator to charge their battery completely defeating the environmental purpose?
It sounds like it initially.
I mean, aren't we just trading tailpipe emissions from the car for tailpipe emissions from a generator?
I get that argument. The emissions math is definitely counterintuitive at first glance, but you have to compare it against the actual alternative.
Which is the tow truck.
Exactly, the flatbed tow truck.
Yeah.
A heavy-duty flatbed tow truck operates on a massive diesel engine.
Right.
And those trucks typically get between 6 to 8 miles per gallon.
Oh, wow. That's terrible.
It's awful. And that tow truck has to drive from its depot to your location, idle its massive engine, while operating the hydraulic winch to drag your heavy vehicle onto the bed.
Which takes forever.
Right. Then it has to drive your vehicle through traffic to a charger, and then drive all the way back to its base. The carbon output of that entire logistical chain is substantial.
Okay, I see the distinction. The alternative isn't some magic zero-emission teleportation. The alternative is a massive diesel tow truck.
Precisely. By contrast, the RH9K utilizes a small, highly calibrated internal combustion engine.
Okay.
And it runs at a steady, optimized RPM that is specifically designed for electrical generation. It's incredibly efficient.
And gasoline is pretty energy dense, right?
Exactly. Gasoline is incredibly energy dense. So that 6.1-gallon tank allows the mobile unit to provide 5 to 10 complete emergency rescue charges before the operator even needs to refuel.
Wait, 5 to 10 rescues on 6 gallons.
Yep. If the service used a massive battery bank to charge stranded vehicles instead, the mobile unit itself would be incredibly heavy.
Oh, right, because it would be a battery carrying another battery.
Exactly, which reduces the efficiency of the dispatch truck. And worse, it would have to be taken completely out of service for hours at a time to recharge its own internal batteries.
Ah, I see. So the gas generator enables true, uninterrupted 24/7 deployment.
It does, and it does so with a much smaller carbon footprint than dispatching a heavy-duty diesel wrecker for every single stranded car.
That makes a lot of sense when you map out the whole logistical chain.
It's all about the net impact.
Now, the sources also highlight a really critical metric regarding the quality of the power generated. It explicitly guarantees a THD of under 3%.
Yes, the THD rating is crucial.
So for anyone listening who isn't deeply versed in electrical engineering, we really need to unpack what total harmonic distortion actually means.
We do, because it's vital for an EV.
Right. Why does this matter so much for an $80,000 piece of technology?
Well, to understand THD, we basically have to look at the shape of electricity.
Okay, the shape.
Right. Alternating current, or AC power, flows in a wave. In a perfect electrical system, that wave looks like a smooth, symmetrical repeating curve.
Just a nice clean up and down.
Exactly. We call this a pure sine wave. This is the quality of electricity that the power grid supplies to a high-end wall outlet in your house.
Okay. So what does a standard generator produce?
Standard, construction-grade generators do not produce a pure sine wave. They produce what engineers call dirty power.
Curry power. That sounds bad for computers.
It is. The electrical wave from a cheap generator is jagged, erratic, and full of microspikes and drops in voltage.
And that jaggedness is the harmonic distortion.
Exactly. That's the distortion. Now, modern electric vehicles are essentially rolling supercomputers.
Right. They're more software than hardware at this point.
Pretty much. And they are managed by a battery management system, or a BMS. The BMS monitors every single volt and amp entering those lithium-ion cells.
Because lithium-ion is sensitive, right?
Extremely sensitive. Lithium-ion chemistry does not handle voltage spikes well at all. So if you plug a modern EV into a cheap construction generator pumping out high THD dirty power, the BMS has to make a critical decision.
It has to decide whether to let the power in.
Exactly. The BMS will instantly analyze the incoming electrical wave. In most cases, a modern EV will recognize that high harmonic distortion and completely reject the charge to protect itself.
Wow. So the car just simply will not charge.
It refuses the connection. However, If the dirty power somehow bypasses those safeguards, the erratic voltage spikes can permanently degrade the lithium-ion cells
Or worse.
or physically fry the microprocessors within the onboard computer.
Oh, man. And I'm guessing that's not a cheap fix.
Not at all. The replacement cost for a compromised BMS or a damaged battery pack runs into the tens of thousands of dollars.
Tens of thousands. So you try to save money with a cheap generator and end up totaling the car's electronics.
Exactly, which explains the strict under 3% THD requirement for the EV Road Hero.
So how does it achieve that low distortion?
The RH9K uses a high-end inverter to smooth out the generated electricity, ensuring that the power flowing into the vehicle is a true, pure sine wave.
So the vehicle's computer literally can't distinguish between the electricity coming from this mobile generator
Yeah.
and the electricity coming from, say, a premium home charging station.
Exactly. The car accepts it perfectly, and the delivery mechanism for that clean power is equally standardized.
What are they using for the connection?
The unit features a 25-foot heavy-duty cable terminating in a standard J1772 connector.
Okay, let's clarify the J1772 for listeners who might just know it as, the plug.
Sure.
The J1772, which is formally maintained by the Society of Automotive Engineers, is basically the universal physical standard for level 1 and level 2 AC charging in North America.
Right. It acts much like the USB-C of the automotive world.
Exactly. It's a 5-pin connector. It has 2 large pins for the alternating current, a ground pin for safety, and 2 smaller data pins.
And those data pins are absolutely critical.
Right. They allow the car's computer to actually talk to the generator, verifying that the connection is secure.
Yep, it negotiates the exact amount of power the car can safely accept before a single volt of electricity actually flows.
The handshake.
Yeah, a digital handshake, exactly. And the RH9K also comes with an included Tesla adapter.
Which is huge, considering how many Teslas are on the road, especially in a city like Atlanta.
Oh, massive. Because Tesla historically utilized its own proprietary plug design before the broader industry standardization, the inclusion of that OEM Tesla adapter ensures that the single mobile unit can interface with virtually every EV on the road.
From a Ford Mustang Mach to a Rivian R1T to a Tesla Model Y.
Exactly. It's universally compatible.
Okay, so moving from the hardware to the economics, because this is where it gets really interesting for the consumer.
The pricing model.
Right. Atlanta Modal EV Charging has established a transparent pricing model that breaks down into 3 consumer tiers.
Right.
The entry point is the Quick Boost for $199. And this provides a 30-minute charge, delivering roughly 30 to 40 miles of range.
Enough to get you home or to a fast charger.
Exactly. The second tier is the standard charge for $329, providing 60 minutes and 80 to 100 miles of range.
Yep.
And finally, the extended charge costs $429 for 90 minutes, yielding 130 to 160 miles.
Which is a massive amount of emergency range.
It is. There are also some clearly stated surcharges, like a $50 after-hours fee between 6 p.m. and 6 a.m., and a $2 per mile fee if the stranded driver is outside that standard 25-mile interoperational circle.
Right, the core zone.
Yeah.
Analyzing these price points, though, requires shifting our perspective on what the consumer is actually purchasing here.
How do you mean?
Well, $5 worth of electricity from a home utility grid does not translate to a $5 roadside service.
Obviously not.
The consumer is not buying kilowatt hours. They are purchasing commercial logistics, time, and emergency dispatch.
Right. They're paying for the convenience and the rescue.
Exactly.
Because if you calculate the unit economics of a single rescue, the $199 fee starts to look incredibly thin for the operator, honestly.
It does. It's a very competitive price.
The company is dispatching a commercial vehicle, they're paying an operator an hourly wage, burning fuel to navigate Atlanta traffic,
Covering commercial insurance, which isn't cheap.
and maintaining complex electrical hardware. The $199 fee is highly competitive when you compare it directly against the $250 to $400 cost of a flatbed tow.
Plus the time saved.
Right, especially when factoring in the time saved by not having to travel to a secondary charging location.
Exactly. The margins on individual consumer rescues are viable, but they are unpredictable.
Because you can't plan when people are going to run out of battery.
Precisely. A business cannot easily scale if it relies entirely on people accidentally running out of power on the highway.
That's a terrible business model for growth.
It is. So the natural evolution for a mobile energy provider, in order to secure predictable high-volume revenue, is to pivot toward the commercial sector.
The B2B side.
Right. The logistics of a single roadside rescue actually paved the way for hacking fleet infrastructure entirely.
And the sources indicate a heavy emphasis on B2B fleet operations, which makes sense because Atlanta is a massive logistics hub.
Oh, it's one of the biggest in the country.
You have companies operating fleets of electric delivery vans, widespread networks of rideshare vehicles, and just vast rental car facilities at Hartsfield-Jackson Airport.
And all these sectors are transitioning to electric vehicles rapidly.
Because the operational costs heavily favor electrification, right?
Completely. Specifically, the cost per mile of electricity versus diesel and the massive reduction in moving parts that require maintenance.
EVs just break down less.
Exactly. But the bottleneck for commercial electrification is not the vehicles themselves, it's the infrastructure required to charge them.
The actual plugs.
Right. When a business decides to transition, say, 30 delivery vans to electric, they face a severe reality check regarding commercial construction.
Because building permanent charging infrastructure is a massive, highly regulated capital expense.
It's staggering. A mid-sized delivery hub cannot simply plug 30 vans into existing wall outlets.
They'd blow every breaker in the building.
Instantly. They have to hire electrical engineers to design the system. They have to petition the local municipality for commercial construction permits.
Which, knowing local government, can stall operations for months.
Oh, easily months, sometimes over a year. Furthermore, they almost certainly have to petition the local utility company to upgrade the electrical grid capacity feeding their specific building.
Because drawing the power required to simultaneously charge 30 large battery packs, that's got to be huge.
It's the equivalent of powering a small neighborhood, all at once.
Wow.
So the business will likely have to pay for the installation of new industrial transformers and heavy-duty switchgear.
They literally have to upgrade the local grid.
Yep. And then they have to hire contractors to saw through concrete parking lots to trench heavy conduit lines.
Trenching concrete is incredibly expensive.
It is. The upfront capital expenditure can easily stretch into the hundreds of thousands of dollars. It often dwarfs the cost of the electric vans themselves.
That immense upfront barrier is exactly what mobile fleet charging seeks to eliminate, isn't it?
Exactly. It's a complete workaround.
Atlanta Mobile EV Charging offers on-site charging directly at the fleet depot. So they are shifting the financial model from a massive, rigid capital expense, building the chargers, to a predictable, flexible operating expense.
Right. Just hiring a service to deliver the energy. The logistical choreography of this B2B service is fascinating.
Walk me through it, because I'm trying to picture it. Instead of the vans driving to a charger and sitting idle, the mobile unit arrives at the depot during the fleet's natural downtime.
Yes. So for a delivery company, this might be a block of hours between, say, 1 a.m. and 5 a.m.
Okay, let's walk through exactly how that operates in the physical space. A single eView Road Hero truck pulls into a delivery lot holding 30 vans.
Right.
They obviously aren't charging all 30 from 0 to 100% simultaneously.
No, the operator functions off a digital manifest.
A manifest of what needs power.
Exactly. They have the duty cycles calculated. Remember, the RH9K unit outputs 9 kilowatts continuously. So if the operator works an 8-hour night shift, they can move down the line. They plug into van number 1 for a 45-minute burst.
Which delivers just enough range for that van's specific delivery route the next day.
Exactly. They don't need 100%, they just need enough for the route. Then the operator manually moves the cable to van number 2, and so on.
And the operator often has remote access or RFID tags for the vehicles, right?
Yep. This allows them to manage the charging sequence without requiring the fleet's actual staff to be present.
So the fleet manager just wakes up and the vans are ready to go.
Exactly. And the mobile service can dynamically adjust to the fleet's needs. If 10 vans had a light route and only need a 10% top-off, while 5 vans were driven heavily and need a 50% charge, the mobile operator balances the load across the night shift.
And the flexibility this offers a business is paramount.
It's unmatched.
Consider a logistics company that leases its warehouse space. If the commercial landlord refuses to allow concrete trenching for permanent chargers,
Which happens all the time.
right, the business would historically be barred from utilizing EVs at all.
Mobile charging bypasses the landlord entirely.
Or consider a business with intense seasonal fluctuations. A package delivery company might operate 20 vans for 9 months of the year, but scale up to 40 vans during the holiday rush in November and December.
Building 20 additional permanent commercial chargers that will sit completely unused for 3/4 of the year represents terrible capital allocation.
It's throwing money away.
It is. Mobile charging allows the fleet manager to simply increase their daily service contract during those peak months.
So they're scaling their energy infrastructure up and down dynamically, to match their exact operational needs.
Exactly. It's fluid infrastructure.
We see this same dynamic playing out in the rental car industry, too.
Oh, rentals are a huge use case.
If a customer returns an electric rental car to the airport lot at midnight with a 5% battery, and the permanent hardwired chargers in the rental garage are currently occupied by other vehicles.
That dead car becomes a depreciating asset. It literally cannot be rented the next morning.
And in logistics, downtime destroys margins.
Completely. But the rental company can dispatch the mobile charging unit to sweep the overflow lot overnight.
Providing enough charge to the stranded vehicles to render them rentable by dawn.
Yep. By offering volume discounts for recurring daily or weekly contracts, the mobile charging provider secures stable, predictable revenue.
And the fleet manager locks in their energy costs without undertaking a massive construction project. It's a win-win.
It really is a highly synergistic relationship.
So, understanding the economics of both the individual rescue and the commercial fleet sweep really brings us to the actual architecture of the network itself.
How the whole thing is structured.
Right. Scaling a service that requires heavy machinery, electrical expertise, and rapid geographic deployment that cannot be easily managed from a single, centralized corporate office.
No, it's impossible to manage something that physical from thousands of miles away.
So EA Rescue has structured its expansion using this bifurcated model, separating national oversight from local execution.
Right. The business model operates with e-rescue functioning as the national umbrella.
They provide the architecture.
Exactly. They manage the primary dispatch software, they develop the national marketing strategies, they maintain the erescue.com digital ecosystem.
And they handle the engineering, manufacturing, and distribution of the actual Eve Road Hero hardware.
Right. They serve as the technological and brand backbone of the entire operation.
But the critical point of failure for any roadside service is the final mile of delivery.
It's all about local knowledge.
If a driver is stranded on the complex, multi-tiered interchange where I-285 meets I-85, an area locals colloquially call Spaghetti Junction.
Yeah, good luck navigating that if you aren't from there.
Right. A centralized dispatch operator sitting in a call center 3 states away is going to struggle to understand the nuances of that exact location.
The invisible infrastructure of roadside assistance is deeply local geographic knowledge.
So eRescue does not attempt to micromanage the specific traffic patterns of Atlanta.
No. The physical deployment, the hiring of operators, and the actual driving of the trucks are handled by local vendors.
And in this specific expansion, the vendor is a local entity named Electric Vehicle Serviceability.
Right, and they operate under the consumer-facing brand Atlanta Mobile EV Charging.
This division of labor is highly effective, isn't it?
It's brilliant, really.
You have national-level technology, the heavily engineered pure sine wave inverters, and the seamless software routing, paired with local operators who actually understand the back roads of Sandy Springs.
Operators who know exactly when the downtown connector is going to lock up with traffic and who understand the safest ways to approach a stranded vehicle on a narrow shoulder.
This network architecture closely mirrors a franchise or vendor license model, adapted for specialized industrial equipment.
Right, it's business in a box.
By partnering with Electric Vehicle Serviceability, whose operations are detailed at electricvehicleserviceability.com, the national network ensures the service is executed by professionals already embedded in the regional economy.
And Atlanta is just the latest node in an expanding web.
Right. The sources outline that this network already encompasses Sacramento, Portland, Seattle, Tacoma, and Vancouver, Washington.
It's growing fast. And eRescue is actively soliciting expansion into new territories right now.
They're currently evaluating markets like Denver, Las Vegas, and Phoenix.
The barrier to entry for launching a complex mobile energy utility has been significantly lowered because of this model.
eRescue provides the hardware, the digital infrastructure, and the operational playbook.
Exactly. For entrepreneurs or existing automotive technicians in regions with high EV adoption but zero mobile charging infrastructure, the model offers a clear pathway to market capture.
And the documentation specifically lists a dedicated channel for these vendor and franchise opportunities. The number is 916-826-9410.
A huge opportunity for the right local operator.
But for the individual consumer, the practical application of this knowledge is straightforward.
Very straightforward. Be prepared.
The industry breakdowns make one point abundantly clear. The worst time to research emergency towing alternatives is when you are sitting on a dark shoulder with a dead battery and a smartphone hovering at 2% power.
That is the absolute worst time.
It is highly recommended to have regional